Good morning, good afternoon, and good evening. This is Dan Backman with Skyport Systems. We're going to start the webinar here. We're very pleased to announce the new availability of Skyport Systems technology. We're going to have a discussion about not only a little bit about the company, where we came from, but also some of the technology that we're bringing to market. I work here as in the technical marketing function. Likewise, Doug Gourlay will be joining us and will be providing some color commentary and a little bit more about the actual technology. So first of all, we're going to cover a couple sections. First of all, we're going to have a quick introduction to Skyport Systems itself, a little bit about the company, about some of the founders and where some of the technology has come from. We're going to introduce you to hyper-secured infrastructure. We see this as the cornerstone of the technology that we're bringing to market. We will also talk about SkySecure, which is what we see as the industry first implementation of the actual hyper-secured infrastructure. And we're going to spend some time talking about how our customers see value in the technology and where we're specifically bringing this product to market. And again, during the webinar, we do have a question and answer capability here, so we will also be able to answer any of the questions that you may have as we actually go through the presentation.
Now, Dan, in my role of adding color commentary, do you want just totally canned softball questions, or do you actually want the hard ones from the audience?
We would like both. In fact, right now you are talking to the audience, so I think we want to have every bit of information that we can about the actual technology.
Yeah, so give us all the hard questions, guys. Throw them in there, make it fun, don't hold back. There's a question, there's a concern, there's something you just even want to get our feedback or thoughts on. Bring it up, ask us, and we'll do everything we can to address all the questions today during the webinar.
Certainly. So let's talk a little bit about Skyport Systems itself. So the company itself was founded 2 years ago to build trusted computing systems. We looked at some of the challenges in the existing security marketplace, and we wanted to address two specific problems. The amount of work that it takes to generate a secured infrastructure, how many different products and services does it take to integrate together to create a secured posture? How do we look at providing a more holistic approach to actually providing a layer of security protection for actual workloads in the enterprise? Likewise, we also want to solve another problem, and that is one of workflow. Think of the amount of work that it takes in order to take an individual workload and bring it to a level of security as you actually deploy that in the enterprise. Now, the team that you see before you has had significant experience in the enterprise. It was founded by Michael Beasley, Will Etherton, and Rob Rogers, all of which have had significant contributions in bringing to market some rather large platforms in terms of the actual networking side of the house, both on Cisco and on the Juniper side. Likewise, we've also closed a B round funding, which has allowed us to strengthen our go-to-market position. And at this point, it has allowed us to bring our technology directly to the marketplace. And of course, Doug Gourlay, I'll pause for a moment and have you introduce yourself as well.
Dan, you want to make me introduce myself. Oh my gosh, you're killing me. All right, so my name's Doug Gourlay, and as we were saying, I previously spent about 5.5 years at Arista Networks. Then before that was 12 years at Cisco. And, the interesting thing is when you see a whole collection of folks with a significant background in security or significant background in networking and systems architecture, a question always comes up is, why are all these networking guys involved in security all of a sudden? And the reality is the type of systems we had all built over the past decade or two were the type of systems that were some of the least compromised systems out there, largely in part due to the systems architecture that we had put in place in building large-scale switching and routing platforms. So, one thing we wanted to realize is how can we bring those types of architectures back to the general enterprise computing framework? And that's a lot of what we're going to talk about today.
Absolutely. Thank you, Doug. So let's talk a little bit about what we're bringing to market. If you look at some of the core tenets of the technology inside of the data centers, there's obviously been a significant amount of deployment in terms of evolution of the architecture on the server side and the networking side, as well as the storage side over time. And what you tend to find is this open systems paradigm has allowed us to quickly evolve and accelerate the adoption of technology in each one of these systems. But as this has happened, one of the things that has also happened is a level of convergence between each of these systems. And this has been happening slowly over time. Originally, we've started to see the advantages that we can get of bringing some technology together, like networking and storage. The network attached storage market is a clear example of what happens when you start to marry some of these technologies. Likewise, we've also seen the same thing happen as we've been able to enable further policy inside of the network by combining some of the security functionality with the actual networking devices. And we've also seen the technology move towards in terms of integrating some of the networking functionality with the server side. Doug, there's an interesting thing that's happening here in terms of how these technologies are lining up. Do you want to address that?
Sure, Dan. In fact, what you've seen is every time that there's been one of these integrations, it's created a multi-billion-dollar market space. I mean, look at the success that Cisco's enjoyed with the UCS server, a phenomenal product, combining server with networking, generating, I think, at least 6.5% market share in the server world, but doing so at very innovative way, bringing new technology integrated to discrete markets. Or we saw VCE, SimpliVity, Nutanix build what they called hyperconverged infrastructure, where they brought the storage world together very tightly with the server. And what we recognized is, and as you had kind of teed up in the intro, Dan, there was a line missing. Very simply, there was a gap. For the last decade, nobody's really been focused on building secure servers. Now, we've seen security integrated with operating systems, and we've seen security integrated with applications. In fact, I would argue that my Xbox One is more secure than most of the enterprise servers I ever see deployed, and certainly is far more secure out of the box than any of the servers that can be acquired. And that's something that kind of threw its hand up, and we looked at it, we're like, oh, wait a second. We used to have secure AIX and trusted Solaris and systems like that. And a lot of them went to the wayside in the last decade with the, just tremendous push towards commodity computing and the tremendous push towards open systems. And as one of our customers said once, do you think for a second that maybe our open systems became a little too open? That, for instance, maybe what we've run into is a scenario where we need that balance between some of the capabilities we had in the mainframe world and secure AIX and trusted Solaris and the capabilities that we've had in the open compute world to bring both of those together.
So let's talk about what this looks like. A hyper-secured infrastructure is really the idea of, can we approach the idea of delivering security not as something that we add on top of the architecture, but as a fundamental property of the architecture. What we're trying to do is take the process of delivering security and make this something that doesn't happen after the fact, and instead make this something that happens by the sheer process of being inside of this architecture, something that happens by default, something that's delivered through the underlying architecture and really becomes a foundational part of the actual architecture. We're also trying to do a couple other things with security. Typically, security tends to be very focused on specific threats. How do we look at signatures for something bad that happened? How do we stop specific types of attacks? How do we intercept various types of protocol level compromises? There's something else that we can do though, and that is we can actually start by looking at what kind of structural protection can we build inside the system. One of the things that's typically very hard to secure against is what happens if you have a workload that has already been compromised.
How do you even detect it?
Absolutely. So if we actually look at how do we solve this problem, at this point, inside of the security marketplace, you could almost have to assume that in your environment, at some point, there has been some type of compromise. And I think we've seen the architecture and the industry really move towards that. So we wanted to be able to provide a different layer of protection. When we talk about structural protection, think of this as something that we build into the system that actually is now, instead of trying to look for specific bad things, trying to make it harder to do bad things in the system. So fundamentally,
you used the analogy once I really liked of the vault. And you're probably getting to it. I'm probably just cutting you off, and I'm probably irking Dan right now. But the reality was he used this analogy once that really hit with me, which was that of a vault for IT. And there's this building we both went to once in New York, and it's 20 Pine Street. And the interesting thing about 20 Pine is it's the old J.P. Morgan Bank building. Now, the top floor, like PH50 or whatever, is really cool because it was Jay Rockefeller's old office, and you can stand up on the roof deck and look down on the New York Stock Exchange, which was apparently his goal. But when you go to the basement of the building, there's the vault. And the building was converted to condos about 8 to 10 years ago. And now, in the vault, is the swimming pool. And the reason the swimming pool's in the vault is they couldn't get the vault out of the building. It is the foundation. The building was built around the vault. And when you go in the vault, if you get in, nowadays there's a pool, there used to be like 1,000 safe deposit boxes that took 2 keys and 2 separate people to open. There was integrated forensics designed to capture somebody doing something wrong. There was integrated surveillance, integrated monitoring throughout the entire system. This concept of a vault was designed to be hard to get into, of course. It was designed to take over 3 days to get in, because that's the longest people would be away from the bank. And it was designed to be really, really hard to get data back out of and get something and steal from without getting caught. And that's what we realized we needed to put in place, a vault for IT systems.
Absolutely. And a vault is actually a great analogy. There's really 3 things that the vault is doing. It's more than just a strong lock and a strong door. It's something that is built into the foundation of the actual building. The building itself is built around the vault itself, and that's actually where a lot of the security practice comes from. Likewise, it's designed to fundamentally compartmentalize the components inside. When you put something in the vault, you know it's secure. It's secure from everything else in the vault just as much as it's secure from the outside, and you didn't have to do anything to your valuables before you put them in the vault to make them secure.
Yet, if you think about what it takes today to secure a server, it's a lot of steps. Now, I'm just even thinking through it. If I went and said, I want to build the most secure server I can possibly get, what are you going to do? You're going to buy a server from a Dell or Supermicro or Quanta or HP or something, and then you're going to have to get them to signature sign all their BIOS and firmware updates. You're going to have them go ahead and shave the physical ports off the back, because you don't want the USB ports on a server. Then you're going to have to use the TPM chips, probably have them soldered down and not be field replaceable, and probably need them epoxied over so they can't be tampered with. You have to use a hardened implementation of an operating system, ESX or some hypervisor. Microsegmentation technologies are taking off right now. Application whitelisting on top of that, sort of a private firewall for each virtual machine that needs to stop things from going out as well as in. Packet mirroring is becoming a very valuable technology people are using today to get deep insights into what's going on, but also for analytics and for redirecting things to IDS IPS systems. There's a host of analytics capabilities, secured file systems, privilege account management. I also need a secure audit log and a security data warehouse associated with the system. When you start layering all these different technologies together and thinking about what is necessary in order to support a truly secured server and infrastructure, it's an incredible amount of complexity. And oftentimes I'm willing to bet that if you acquired all of these discrete systems, they're frankly not even designed to work together, much less having the people, the time, and the available resources and cash to support this type of infrastructure on the systems most necessary to apply this level of security. But then, and I kind of already teed it up and went to the slide, but okay, that's a lot of stuff, right? I mean, there's going to be a set of customers who look at this and go, it's absolute overkill for every workload. Are you kidding me? You're a new company. You're telling me you built a server. I'm not going to buy a server from a brand new company and deploy it globally. You must be joking. I said the same thing to our founders when I joined. So where does this actually make sense? What type of workloads and where in an enterprise, like what place in the network does this type of infrastructure make sense for?
So we see the vault analogy as actually being pretty accurate. What we really want to see is we're trying to secure highly critical systems and expose valuables. We want to look at effectively 3 different use cases, one of which is if you have systems that are fundamentally exposed, if you're trying to protect something from the outside world, That's something you would put in the vault. Think of the services that are exposed in the DMZ. Now, this vault is giving you a couple things, one of which is very tight policy control over what goes into and out of the system, and also a layer of surveillance and audit, so that not only are we controlling the system, but we're also providing a level of audit on what is allowed into and out of that system. So if you have something where you're trying to secure these assets in this demilitarized zone, this is actually something that we would see going inside the vault. On the other side of the spectrum, it's also something that's designed to deliver a physical hardware platform that's designed to be hardened. It's also designed to be hands-off managed. So there's also a set of use cases where we can protect workloads in remote sites where you don't have direct physical trust in the location. So in this case, it's almost as a vault, but it's almost more like an embassy. Think of where you need to establish sovereignty in a remote location, whether this is a branch office, whether this is a remote manufacturing site. And the last one is actually most interesting in terms of the IT infrastructure landscape. There's now a whole new set of services that are critical control points inside of the data center. Think of things like management or orchestration servers, controllers that run the infrastructure itself. These are high leverage points of attack, and this is exactly the type of workloads that we would see running inside the system. So we almost see this as effectively the new class of protected resources inside a data center, management vault, if you will. Think of your vCenter servers, Active Directory, critical IPAM systems, things like that.
If you think about it, every CIO I know in the last 5 years has turned on 3 of 5 of these type of critical systems. Everyone's done a single sign-on project, a virtualization project, a big data project, a private or hybrid cloud project. And the outcome of that is a small number of very, very critical systems that unfortunately, have become attack points and, part of the, target systems that someone has. Now, bad pun on that, really. So let's think about what are we introducing, right? To be really, really blunt, what we've built starts with 3 core components. First, we're delivering a trusted computing system. This is a physically hardened, tamper-resistant server designed to be put on-prem and designed to be put in locations where you may not have the level of physical security that many people have in their most advanced data centers. If you have a server in a branch office, it's designed to be that type of device, or even what we call a hostile computing environment. Now, in software, accelerated through the hardware architecture, we shrink the security perimeter around each virtual machine that's landed on the system. This means that there's effectively a private firewall controlling everything going in and out of that server, of that VM. Now, when I say in and out of, it's a little bit different than what some people think of as a normal firewall, in that it's a zero trust firewall. We don't trust what's on the inside, and we don't trust what's on the outside. If something goes ahead and starts violating policies, not only could we reset a workload to a gold master, we could also turn on hardware packet data capture and capture what is violating the policy and potentially capture a control channel that's being used as part of an exploit. Now, the other piece of it, and probably one of the most critical aspects, is that security is hard. It changes. Our goal is to deliver for our customers a unit of compute capacity, but more importantly, an ongoing security capability. So we've designed the entire system to be delivered as a service with integrated management, central and remote attestation services, and the core concept of a lifetime security data warehouse and traffic analytics engine that captures every single transaction going in or out of the system from the very first day it was made in manufacturing, where the initial record is a photograph of the hardware, a photograph of the mainboard, signature signed and keyed with the same key put into the hardware security module of that server. In short, our customers can verify that a system has or has not been compromised physically, logically, at an application layer, or even down to the hypervisor level. The system verifies on boot that there are no rootkits, that there is no malware. This is what we call an engineered system. It's hardware, it's software, and it's delivered as an integrated service. And in this case, it's a hyper-secured infrastructure system delivered as an engineered system with full stack integration.
So one of the things we may want to also cover is how do we experience this system? So at a high level, you have an on-premise component. It is designed to deliver compute. The way you interact with it, think of this as a hyper-secured environment that hosts workloads. Today, a workload is a virtual machine.
Yep.
Just like a bank vault, we want to make this easy to put systems into and take systems out of. You inherit the protection by being inside the system. So by leveraging hypervisor technology and an integrated orchestration system, it's easy to move a workload into the system. And we can also do this programmatically because everything is entirely built using an API-driven system.
So when we look at the hardware itself, now what we built was we took a stock sort of off-the-shelf Intel server built by Intel Systems Division. And in this server, it has 16 cores, 128 gigs of DRAM, two 1 terabyte SSDs that are fully protected. More importantly, we've taken off the ports. We've made the system completely, we've reduced the threat surface of the system. Then all of the I/O goes through a SkySecure I/O controller. This has a very advanced Cavium processor on it and parses all of the traffic going in and out of it. The SkySecure controller logically sits with the server installed inside of it and connects to the PCI bridge and uses what's called SRIOV, or single root I/O virtualization. This allows us to express a single instance of the NIC to each and every workload that gets landed. But you also notice that the system has two TPM chips, the Trusted Platform Module chips. Keeping to our model of a zero trust architecture and two-man rules, what we've done is it has two TPM chips, one on the I/O controller, one on the x86 subsystem from different vendors. One's from Infineon, one's from STMicro. When the system first boots, the TPM chips do what's called remote attestation. They read a signature from all the hardware components, from the BIOS sizes, from the firmware, from the software build on the system, and they exchange that back to a remote attestation service that we've operated that knows what each server should be looking like based on the key that was placed there and based on the sizes of the signature signed images that have been delivered to that specific unit. When the system boots, we verify all the signature sizes. The system then gets a clear to boot coming back from us, and at which point the system boots the SE Linux operating system. It's a version of Debian that was then we've very much stripped down. We've loaded into DOM0 on the x86 and loaded onto the Cavium on the I/O controller. SE Linux is rather unique in that it's a full whitelisted operating system model where each process is required to have a specific whitelist entitlement for what other processes it's allowed to communicate with. But a bit of history, SE Linux was introduced by the US National Security Agency in 2004. We found it to be rather difficult for customers to implement. In fact, most customers we've talked to said it's almost unusable in its difficulty, or they run it in pure open mode. What we did was we had to write our own compiler so that the processes, the inter-process communication would be part of a compiled and validated set of configuration that was created at build time based on all the processes that were enabled in that particular build and that signature signed image. Then, as customers import workloads and import virtual machines onto the system, the SRIOV is a method of containment. We create a unique instance of the NIC and express that to each application and operating system. Then, we're either experiencing intense traffic volumes, a denial of service attack, a distributed denial of service attack, or webcast technology still sucks. I'm actually not sure which one it is. I'm going for door number 3. Just kind of putting that out there. I'm glad this is being recorded. There goes my career. or go to webinars, not likely to be a customer tomorrow. Or maybe they will be, who knows? But the SRIOV lets us express a unique instance to each one of the applications and operating systems that are landed on the system. Now, Dan, do you want to talk about what happens once a workload is on the system, what the software stack does around it? Because there was that interesting hollow thing around each virtual machine, and we probably need to explain what that is.
Absolutely. So what you fundamentally get when you onboard a workload inside of the SkySecure system is you get a layer of protection. So our goal is we want to be able to inherit security protections from the hardware, and we want to make it get as close as possible to the virtual machine without going inside. And the way we do this is actually to create a complete artificial network environment with a perimeter directly around that workload. Think of this as an application-specific perimeter. This is what we actually call the SkySecure compartment, and this is where you realize the security protections inside of the system. Now, this is actually something coming directly from hardware. As we looked at part of the hardware, the first thing you notice is it's actually designed as two different systems. What is different about a hyper-secured infrastructure? It's not software protecting software. We're not relying on software inside of the workload. We're not relying on software that is running in the hypervisor. Instead, there's actually a hardware separation in the underlying environment that is providing these protections. So that I/O controller that we talked about is actually where these protections are being rooted. And we have a hardware separation layer that is actually keeping each one of these virtual machines completely compartmentalized. And this compartmentalization is something that you see that we're giving your workloads, but it's also going up and down the actual stack itself.
So let's talk about those specific things in the software compartment. Like, what are these different shields, Dan?
So the goal of the compartment is to really do three different things. If you're going to compartmentalize something, we're doing this to protect against specific threats. We're doing this to contain and police the communication. So this is also what makes this workload hard to not only break into, but also break out of. And there's a layer of visualization. All three of those things are happening rooted in that hardware. Now, as we start looking at what we can do to the actual protection layer, we've implemented a policy engine that allows you to dial protection up from layer 3, where you're doing things like application whitelists, also layer 3, layer 4 policy directly built into this whitelist engine. But also through policy, we can dial it all the way up to layer 7. Now, just like a bank vault, one of the things you want to do in this bank vault is not only make it hard to break into, but also make it hard to steal things out of that system. And as part of that, this is exactly what we're doing. Think of what you do with a die pack on money. You're trying to make that money hard to spend outside of the system. Well, we're doing something very similar inside of our compartment. Now, the first thing is, what can we do at the application level? We can actually mitigate certain threats. In this case, using Shield Web, we have the ability to actually completely intercept at layer 7 web communications. Think of a DMZ scenario. You may have a workload. It may have an older version of OpenSSL, and it could be vulnerable to various attacks. And at this point, it looks like these are coming up about once every 2 to 3 weeks now?
Maybe not that frequently, but there's certainly a lot of them.
So the challenge is, how quickly can you update these externally facing services? If you have a web server that is vulnerable either to Heartbleed, Poodle, or one of these latest attacks, there's a lot of these protocol backdown attacks that we're starting to see. Well, how can we actually start to mitigate this? By intercepting the traffic at layer 7, we can actually fully compartmentalize the actual protocol communication and upgrade it. So one of the use cases that we have is for DMZ-based services, you can actually mitigate against something like Heartbleed, Poodle, also some of these newer protocol backdown attacks by actually terminating these inside of Shield Web. We can upgrade the encryption, we can restrict the cipher suite to same non-exportable ciphers, and likewise, we can also allow you to do another cool trick. If you want to actually start to make things harder to steal, what's something that you may want to steal from a DMZ server offering TLS, Doug?
The private key, the password, the root certificate, something like that.
What happens if that's never actually inside the VM?
Then I can't steal it.
That's exactly what the compartment does. So in addition to actually upgrading the encryption, you can also now take things like credentials and pull them out of the actual VM itself. Making these are the types of things inside the compartment that an attacker is looking to steal. How do we actually remove these keys so that they actually have less to actually steal once they break in.
So to be very clear, it's for instance, when every person who registered and is attended, when you hit the registration page that Citrix GoToWebinar offered, if you noticed on the top left, it had an expired, outdated security method. It was using TLS 1.0 with a SHA-1 hash, which has been deemed insecure. Your browser may have flagged that. If that was running on this system, they would not have to go back and rekey it. They would not have to change the crypto library, retest or recompile the application. They'd simply import the application onto the SkySecure server, preferably move the private key into the compartment, at which point the cryptography would be upgraded to TLS 1.2, maintained to the current standard and specification necessary to make client browsers happy. But it would actually, and this is very unusual in security, be a benefit back to the application developer, that they would not have to go change things. Or when Heartbleed 2.0 comes out, Tuesday morning, it's a mad scramble of people to catch up, change their libraries and things like that. They wouldn't have to do that anymore. They'd be able to automatically upgrade to the latest cryptographic methods and mechanisms without recompiling, retesting, or rebuilding applications.
Absolutely. And there's also an interesting scaling advantage here too. Proxy technology isn't new, but typically this is something that you implement in the middle of the network. You're looking at how much performance can I get for scores or hundreds or maybe even thousands of nodes behind it. What you now have is you're attaching this to the actual workload. There's an advantage in providing these security benefits directly inside the compute architecture because it scales up with the actual system. Now, we're not limited to just web. This is just one example.
So there are 5 down here. So tell me about them. What are they?
So one of the other things is if you're looking at what types of things would you want to control in terms of this compartment, file access is actually one of the big ones.
That makes sense.
So
think of that.
Think of the credentials that you have when you're accessing external systems. Well, let's say you want to be Bob on the inside. Well, the problem is if Bob's credentials get stolen, this now becomes a vector of attack.
So I can privilege escalate potentially, or have at least access to everything that Bob and his password have access to around the entire enterprise, because it's probably the same username and password everywhere.
So what if that Bob and password of ABC123
was locally significant?
Exactly. What if it doesn't matter anywhere else?
I'm playing a really bad straight man, aren't I?
So there's actually 2 things that this does. It actually separates this workload from actually having to have these keys to access the external resources, but also it's a canary. If it's locally significant
and it's used somewhere else,
clearly you've stolen it.
That's kind of cool. I like that.
There's another interesting trick here. If you start looking at access credentials, you can start using some pretty powerful authentication systems, especially token-based authentication systems. Once you start Kerberizing these services, you've established a very secure method of authenticating and authorizing file access. The problem is you've now given out effectively a very powerful ticket that you can use to the outside world. It's more than just a username and a password. This is now part of a single sign-on credential. The other advantage of this system is even if you're using Kerberized CIFS access on the outside, you can also now keep the Kerberos token in the compartment. It never actually exists in the virtual machine. So even if that workload is compromised, all he ever has is that password of 123, not even the Kerberos token to access these external resources.
So a pass the ticket, pass the hash attack also, one of the hardest things to prevent against, it mitigates the likelihood of the theft of a particular ticket or hash because it's actually not on the system at all.
Precisely.
Now, the couple of the other ones at the bottom, I don't think we have specific slides on them, but Shield Admin, as I understand it, logs RDP, VNC, and SSH connections in and out. Could provide IP geofencing and technologies like that, so that management can only come in from, New York or America or wherever your server you want your management access coming in from. We could filter out management can't come in from, CIS or something like that. Or if you're in CIS, management can't come in from the US. Right, it goes both ways.
Absolutely.
Okay. There is more. Shoot, I got completely ahead of myself, Dan.
So there's more than just protecting credentials. So the compartmentalization of credentials gets really interesting. Once you're at the application layer, you also have visibility into content as well. So we've also built in an extensible content inspection engine.
Regex based or?
It's more than that. It's actually designed so that we can extend it. We can start with something as simple as a regex and then start extending that to support different types of file types, different terms of external matching criteria. We can start looking at how do we dynamically pull information from an outside system that's actually compiling lists of things like PII, and how do we automatically start looking for that type of information.
Very cool. So, for example, then, we could lock a file down so that the VM uses Bob's credential, but what actually comes out is Alice's. Alice's credential can see a particular volume and share on a central NAS head. But the VM container, the compartment here, locks it down so that it only sees a specific directory, subdirectory, XLS files written by user Dan in the last 24 hours that are unencrypted. As the file gets read in, it gets parsed by the compartment and inspected for a regex match or further deeper analytics, but specifically looking for, in this case, credit card numbers, copyright statements, confidentiality statements, source code identifiers, and things like that, which then stops that file from ever getting read into the VM, where it could be then hijacked or repurposed for a data exfiltration.
Exactly. And it's not just controlling content, it's also audit. We're aware of actual activity at the file system layer. We know when things are being read and written from. So all of these are things you can also start to build into an external audit scheme as well.
Very, very cool. So let's look at the fancy UI, because no security system is complete nowadays without the associated fancy UI. What you're seeing on the left here is the base homepage. The base homepage is designed to pull your eye to resource utilization issues. Either you're about to run out of a resource, system availability, system access to management station, so on. On the right is one of my personal most favorite reports I've ever seen created. It has the fancy name of a Sankey diagram, but we call it the Traffic Intelligence Report. On the blue vertical bar, you're identifying a single workload, a virtual machine, or a VM hosting multiple containers. The green line gives you directionality. The purple vertical is segmented into port and protocol within that particular direction. And the purple line is segmented into fully qualified domain names or IP-based destinations. But this isn't the last 5 minutes or the last hour or just how long you've turned on the particular traffic monitoring for. Up top above this, you select the date range that you want to look at, which is every bit of traffic and flow and transaction for this server from the day it was turned on to current. You select the day or the date range. You then select the window, which is the blue highlight that you care about. It dynamically creates the traffic intelligence report, which lets you see what your workload was doing. Then I can select a particular band of traffic, see the extrapolated tabular data below that is effectively the IP fix information about the collection of flows to that particular destination with that port and protocol, sourced from a particular workload in a particular direction. And then I can create a whitelisted entitlement saying, please continue to allow this traffic, or a blacklist, even now while in observation learning mode, a promiscuous mode, deny that traffic because we know this workload shouldn't be going to windowsupdate.com or wherever.
So that sounds like a lot of data. It sounds like something more than we want to keep on an individual server. How are we providing that depth of data?
It's a good question, Dan. And actually that leads to a question that came in from our friend Lakshmi, which is, how do workloads mean tenant applications only and business applications? How do these get orchestrated and so on? We've actually created a centralized security data warehouse that is designed to be write only and not change enabled, where all the logs get centrally written. And what it does is provides a central correlation across tens to hundreds to thousands of systems for a customer, but also is designed so that no individual credential, no user, for instance, no admin, can actually go and change the particular log. Even if you go to Reddit today and you start reading on the NetSec group in Reddit, there are people posting up there how to go erase your footprints from the software logs on a server, how to renumber a PCAP file so that you disappear. You can't do that when the system is completely off-board. There's no hard drive that can be stolen out of your facility if physically compromised. There's no system on-prem that they can east-west hop onto to shut down the log or delete it. It really gives the customer the maximum assurance that the log file is immutable and can't be changed. And it really comes back to a story. When I worked at Cisco, there was a gentleman I had the undoubted pleasure of working with named Terry Childs. And Terry was an SE at Cisco, and well, we terminated him because he was a little strange. Probably shouldn't say that, but he was. But I have reason to say it now because 6 months later, Terry appeared working at the city of San Francisco as a network administrator. And if anybody wants to read the full story, it's worth Googling Terry Childs Network. But what you'll find was he got a little frustrated at the city and decided to lock the entire city out of its network, changing every password and doing a write mem on every switch and router. And what you found was, with that, Terry actually went to jail. And Gavin Newsom, the mayor, had to go meet Terry in jail to get the password from him to restore the city network. And that's an interesting challenge for us because how do you prevent, I hate to say it, the rogue admin, or even a worst case scenario, an administrative credential getting stolen and getting misused, and then deleting their tracks because they can edit and change the log file. So what we want to ensure is that we have an accurate data set for every transaction, every manager login, every policy made, every time a system boots or shuts down or is reimaged, every time a VM boots or shuts down or is reimaged or is PCAP'd, every change to policy, connections blocked, traffic denied, management access. This gets really, really powerful when you can look at something and go, oh, look, here's a server. And it did a net use, decided to try a recon attack effectively on LDAP and Active Directory to see what resources were there. Then it did a ping scan. Then it did a port scan of a particular host. Well, that's bad. And it's kind of bad if you find out that Dan the admin was logged in at the exact time that was happening and you can see it all right there. You call Dan and go, Dan, did you do it? Yeah, I was testing something out. Okay, don't do that again, Dan. Or, no, I wasn't logged into anything and I didn't do it. Well, now we know Dan's credentials may be compromised. Or possibly even worse, you see ping scans, port scans, any traffic that violates a connection. And what you find is no manager was logged in. No admin was logged into a system. When you see that, what you realized is somebody is doing something that it never should be doing. Now, it's hard to monitor this for end user computing because I don't know what websites Dan or Doug or Kim or anybody's going to hit within the next few minutes. You don't know what web pages I'm going to pull up as soon as I'm done with the webinar. But I can tell you, I know exactly what my payroll system's supposed to be talking to. I know what devices my DNS server supports. I know where my Active Directory domain controllers are and who authenticates to them and where they do synchronization to read only Active Directory edges. I know what my print servers are supposed to talk to. And that's what makes it very interesting. When you know what something is supposed to talk to, you are capable of implementing whitelists. If the whitelists are mapped to DNS entries and dynamic global objects, it gets much easier to manage them. And if a business application starts one day doing something it has never done before, you may have a new image that just got loaded, but I can see that. A manager logged in changing something, but I can see that too. Or somebody compromised it with a zero-day attack on an unpatched version that, okay, I'm sorry, but every workload is capable of getting compromised by a zero-day event or an unpatched known defect at some point. Well, the question isn't did they get in? The real question is what can they get back out? And if we can mitigate that so it's hard to get in, it's incredibly hard to expand, and it's damn near impossible to get information and data back out of the server, at that point, you've contained the breach. You know where they're at, and we can restart the images, or we can restart the system to known gold master images. So Dan, why don't you talk about one of the first use cases? This one went live this week, if I remember right.
Absolutely. So one of our first customers is actually was really interested in specifically protecting against a challenge of moving intellectual property. It's a DMZ-based application. This is one of the use cases that we talked about at the top of the hour. And they're interested in a couple things. First of all, how do they lock down and whitelist the actual communications? These are known IP transfers. So how do you start to actually provide a layer of automated control over who's allowed to do these transfers? But more importantly, how do you provide audit? How do you know exactly when these transfers are happening? How do you know that the system isn't doing anything else other than what it's designed to do? This is actually one of the key use cases behind it. What they were able to get with this hyper-secured infrastructure is a layer of security that's always there. Even if a system is probed, we can actually control that traffic. We can control exactly what it's allowed to do. And at the end, you can always come back and look at every one of these transactions into and out of the system. It's almost like attaching a flight recorder to this type of critical system.
I kind of like that. And it actually gets to a scenario we saw with a conservator bank we were talking to, and they had the requirement, and it was like a big FINRA regulation, but it's something along the lines of they're using FTP and DMZs to move billions of dollars of financial transactions each day at the end of the day. But at the same time, what they've realized is they have to verify the remote side's DNS. They have to verify the remote side with IP geotagging. They have to encrypt with something along the lines of AES 128 with using a SHA-2 hash or something like that. Then they have to get a hardware packet data capture of all unencrypted data being sent, so they have evidence about what actually was sent. And they have to do a DLP check on it to verify that of the files sent, they're not sending source code or data that wasn't supposed to be in the package that's being sent to their partners. Today, that takes between 6 and 7 systems for a customer to build that and set that up. And it's a very complicated, and frankly, it's a very fragile chain. It's like a webinar. With audio quality issues. It's a very fragile infrastructure, as all of us get to experience. But what we've also realized is now we can build that into one system, and that's what makes it very, very interesting. And by the way, I want to give a special shout out to our friend Lakshmi, who's asked by far the most questions, but also asked really, really good questions of us on the question manager. So anybody else, please feel free to read out or write in any questions you have. And Lakshmi, if you could send us your mailing address. We have a couple cool Skyport launch swag T-shirts and such. We'd love to send a few over to you, and we really appreciate your interaction. So thank you very much for that. And the more the merrier. I will gladly pimp out T-shirts to Christoph, Lakshmi, and anyone who's asking questions. So send us some more. We really do appreciate them. It helps all of us know where to make our message better. Why don't you talk about the next one, Dan, that I thought was really cool just because of the responsiveness and timing that worked in conjunction with the SecOps team. Tell me about this.
Yeah, absolutely. So one of the key pieces of functionality that we're giving here is visibility. The question here is, why are we doing security as part of infrastructure? There's a couple reasons. One, because it's something tied directly to your workload. And two, it's always on. So if you start looking at how do you know that your system is under attack, this is a typical thing that you'd hear from most security vendors. What's different about attaching this to the infrastructure layer is that it tells you not only who's coming through the perimeter, it also throws up red flags when you're getting probed and attacked from your neighbors inside of the organization. This is really the key of collapsing the perimeter all the way directly around an individual workload, and also adding this level of visualization. The other key here is not only can we quickly analyze this data, and at this point, in terms of the technical details of what we're doing, think of this as the equivalent of having a NetFlow probe attached to every single workload. You're getting flow level visualization as we looked at in the actual UI, but also we give you the ability of doing packet level control and mirroring so that we can also start to build an evidentiary trail. So with this level of instrumentation, it quickly allowed this customer, this R&E university, to be able to quickly see attacks from different parts of the network, both inside and out, but also provide an evidentiary trail on top of that.
But yeah, I like that, Dan, but I have to say what I think was most important in my Siskel and Ebert view was that you could identify that something was happening quickly and then shut it down. Turn that, say nothing outside of ouruniversity.edu can get to this Active Directory domain controller. Very simply, in a couple lines of policy, shut that down, and then go back to the central SecOps team and say, why were these outside devices able to get through the edge firewall and get to my particular host? And that gives us a very, very powerful response. I can see what is happening on my application, and I, as the app owner, can control its destiny. I can turn something off if I need it turned off. I can open up the interface if I need it opened up. And then I can recognize if something's getting through the outside firewall to my host that shouldn't, I can stop it immediately and then have all the data, like you indicated, to communicate back to the SecOps team and go, this is what's coming in. It's clearly coming from this source. It's going through one of your policy enforcement points or more. Let's have the data to build that coordinated global response. And I know as we get near the end, which is pretty darn cool. Dan, I didn't even know you and I could talk for an hour together, which is actually scary because Dan and I usually never shut up. But the summary of benefits that we see, security by default. Okay, to make it very blunt and simple, you take the box out, you plug it in, you turn it on. It is as secure as is possible for us to make a product out of the box. Everything you do after that is designed to keep it as secure as possible, and the service level is to maintain the security posture of that device over its life cycle. There's a system provenance and a reduced threat service. We've verified our supply chain. We know where all the components are coming from. We're verifying the BIOS, we're verifying the firmware, and we're signature signing all BIOS, firmware, and software updates. Signatures are being published publicly so you can further re-verify all image distribution. We're securing the audit logs, building a tamper-resistant log that no admin can just pick up the hard drive and steal. And even worse, no bad person can compromise a credential and do something with. And the idea is to track policy, access activity, and never again have an enterprise or carrier have to stand up and say, we don't think customer records were stolen and we have no evidence that they were. And then I get my third free LifeLock account in a year. And then lastly, from an insertion perspective, there's a lot of technologies people are approaching the market with that require galactic reformation, deploy our system, deploy our agent everywhere. And one of the challenges of agent-based technologies, which by the way, I love what they do, but just one of the inherent challenges is that an admin oftentimes can opt out or turn it off. When I'm doing the build on my application, I could say, nah, turn that one off, and that one off. I need to troubleshoot something. And if that fixed your problem, they never get turned back on. I was at a large size healthcare insurance provider the other day, and they told me they have a team of people who go around and whack the app developers on the head to say, hey, turn this agent back on, we need it. And that's it. That's created a job, or actually a couple people's jobs, which is a problem. So when we talk about no change in the environment, it needs to not only be something that you can import a workload and improve its security posture, or deploy the right hardware, put workloads on it and improve multiple workload security posture. It also needs to be something you can deploy incrementally. By just loading one workload, you improve the security posture of that workload. By deploying 10, you improve it for 10. Or by importing 10 workloads, you improve 10 workloads. If you want to do more, do more. But what we're really advocating today is look at those mission critical systems that can create significant outage or challenge in your environments if they're compromised. Look to the areas where you put compute that is less secure physically, or in areas where new markets you may be physically moving into geographically that create challenges in those areas. Those become interesting points. And look at the DMZ. Because oftentimes I've seen DMZs that are still running Trusted Solaris or Secure AIX because they haven't been able to move to Windows or Linux with confidence. and be able to say, I can move to Windows, Linux confidently and run them on top of a trusted platform in my DMZ. And then have the level of security necessary to be able to offer improved services and be able to put more information out there and integrate with your partners and such. So design it to roll in and roll out quickly without changes to the network, without changes to the app, without changes to the OS, incremental deployment. Now, a lot of questions came in. I believe our online team has answered all of them. And I know we really are at the top of the hour. So with that, I'm going to say thank you very much for your time, attendance, and attention. We're very happy to go one-on-one and have any conversation people have. Feel free to email us. I think info@skyportsystems.com is one of those global aliases that hits all of us. And feel free to shoot us an email. Feel free to contact us. And for those folks who asked a lot of questions, like Herman, Lakshmi, Michael, shoot us your contact info where we can send you a nice new Skyport T-shirt, and we'd love to share that with you as well. So thank you all very much for your time and attention, and we look forward to getting to know you all better. Thank you.